So I want to talk about this problem here. And the reason is we're approaching x from the right. What if we wanted to approach x from the left? And we actually were not able to. One thing to keep in mind with these one-sided limits is that we want to look at the graph of the function to see what's going on if we can. So if we approach from the left, we approach from the right, we could have a situation where no matter which side we approach from, we're heading for the same limit point. So we can say this is C. We could also have a situation where there's a jump. Approach from the left, approach from the right. In this case, depending on which side we approach from, approaching from the left, we're going to end up down here, but approaching from the right, we're going to end up here. So our two-sided limits won't be the same. But another possibility, and this is what we're looking at in this problem, is you can approach from the right, but we don't have domain over here that lets us approach C from the left. We don't have that. So in this case, we want to take a look at what's going on with this function, see if we have any holes in our domains along the x-axis. So for this, we can try to figure out what's going on. So we have some points here that are going to be significant. First off, let's see where this crosses the x-axis. So to do that, let's set it equal to 0. So we square both sides. Multiply both sides by x plus 2. And then we get x is 1. So at x is 1, this is crossing the x-axis. Now, from what we have, this is the only place where it's crossing the x-axis. So that being the case, we're going to be interested if is it doing something like this, or is it doing something like that? And the way we can tell is we can do what's called a test point. Say x is 10. So we'll get 10 minus 1 over, say, 10 plus 2. We get square root of 9 over 12. And that's going to round down to square root of 3/4. But this is a positive number. So if you remember from algebra, we're going to have a crossing here. And then everything on this side is going to be positive. And the function doesn't cross ever again out here. So it's positive from here all the way out. And here it's equal to 0. Now, let's take a look for points that make this thing undefined. So 1 is when the denominator is 0. We get a division by 0. So we can do this, -2. So at -2, it looks like we're getting a vertical asymptote. Now, again, this only crosses the x-axis at one place. So to figure out if this function's above or below the x-axis, again, we could use a test point, see what's going on here. So let's say we let x be -10. So the square root of -10 minus 1. This looks kind of dangerous. Looks like we're going to take the square root of a negative. Then we have -10 plus 2. So we get -11 over -8, but negative and negative are positive. So we're going to get a positive 11/8. So over here, it's going to be positive. So probably what's happening is the function's doing something like this. So it's positive here, it's 0 here, and it's above the x-axis here. So far, so good. We're getting an idea of what this thing is doing. So now we got to figure out what's going on in between. Well, we can use the test point to get a hint, and then we can do a little bit of discussion to figure out what's going on. So let's say we use x as 0. So that's going to give us the square root of 0 minus 1 over 0 plus 2. Or we get the square root of minus 1 over 2. And we've got the square root of a negative number. And that is undefined, at least for us, since we're dealing with real numbers. So at 0, we've got something that's undefined here. So let's talk about this. If we choose any number between 0 and 1, so if we let x be between 0 and 1, that means we're using numbers. X is smaller than 1. So x minus 1 is less than 0, but x plus 2 is greater than 0. So that means over here, x minus 1 over x plus 2 will be a negative number divided by a positive, which is negative. So that means when we take the square root of this, we'll be taking the square root of a negative number. So this is all undefined. So let's now consider x between -2 and 0. Well, in this case, x is a negative number, so x minus 1 will be negative. X plus 2, well, x is a number that's between -2 and 0. So like -1.5. Well, -1.5 plus 2 is still positive 0.5. Even say -1.9 plus 2 is going to be 0.1. So the bottom line is that when x is between -2 and 0, x plus 2 is positive. So once again, x minus 1 over x plus 2 will be negative divided by positive, which is negative. And if we try to take the square root of this, taking the square root of that, again, this is undefined. So in this case, if we're trying to take the limit as x approaches 1 from the left, we can't get close to 1 coming from the left. The closest we can get is -2, and that's it. We can't get any closer than that. And so what we're going to do is we're not going to take the limit here to say that we're in a neighborhood of x equals 1 on the left. We just simply aren't. So for that reason, that's a good reason for not having a left-sided limit. We're only going to consider the right-sided limit for at least relative to 1. So if you have any questions about that, let me know. So just something to mention.